Our capstone group was with Rogue Credit Union. Capstone is a 3-term sequence that computer science students have to go through that requires a hands-on real-world project, often in the community, to better prepare themselves for success in future jobs. Capstone projects vary in type and scope. They can range from web applications to database implementation to mobile apps and everything in between. Our team was lucky enough to have paired with Rogue Credit Union to document and create a financial simulator web application. A little bit about Rogue. They were founded in 1956 by 10 elementary school teachers in Medford. They currently have over 184,000 members. They have assets over $2.9 billion. In 2012, they merged with Chetco Credit Union, and in 2021, they merged with Malheur Credit Union. Hundreds of employees currently work at Rogue, and they're constantly growing. The CEO of Rogue Credit Union, Matt Stevenson, runs a yearly management class that includes a credit union financial simulator exercise as part of its curriculum. Important terms and definitions that we're going to use throughout this presentation. A cohort is a group of teams sharing the same simulation parameters. A team is a real-world team represented by a single representative in the system. A simulation year is a single calculation cycle within the program. Decisions are variables input by each team for each simulation year. Constants are values that are referred independent of the simulation years. Factors are variables representing the initial values or baseline on which yearly calculations are based. Variables are values that have relationship with each simulation year and may change per year. Example of some of these terms being used are the financial simulator exercise is conducted yearly with a cohort of teams competing over 7 simulation years. The teams make yearly decisions, the values of which are paired with constants, factors, and variables to calculate results. Motivation behind this project. Currently, the simulation is operated by the use of a very complicated Excel spreadsheet. That spreadsheet contains around 75 individual sheets, tracks thousands of data points, uses hundreds of individual calculations, dozens of circular calculations. It requires significant manual interaction by the administrator. It's resistant to change, so changing a single calculation could involve editing up to 60 sheets. Results are not easily shared with participants. A typical simulation contains up to 20 teams and can run for 7 years. There are around 80 variables that are preset for each of the years, totaling over 500 values. There are around 120 result variables per team, which is almost 1,000 per simulation per team. Every cohort gets an independent set of these values. Therefore, a cohort can have an estimated 20,000 values stored in it. The current process, this decision sheet that you see here is printed out and handed out to teams in one physical room. The teams then fill it in with data like you see here. The admin has to collect these decision sheets and enter those values manually, and that's 20 decision values for 20 teams, could be up to 400 values. They're then calculated into these forms: the income statement, the balance sheet, the key data report, the loan stats report, and the deposit stats report. And then this is repeated for every simulation year, which could be 7 times or more in a single cohort. This is an example of the summary that can come out of that and the amount of data that there is.
So over the course of 2 terms, we developed a Django web application that migrated the Excel spreadsheet into this application. And with the application, it requires less manual entry by the instructor. It allows for future expansion, more control, while keeping levels of abstraction from users. It allows for more input validation and is easy to share desired results and hide other values from users. It also allows the admin to choose when to proceed the simulation as well. The technology we used was a Django web framework. It's based on Model View Controller, which I'll explain in a little bit. And it's easy to deploy and manage. It's scalable, and it has simple database options. Some of the major requirements and features that we identified were grouped into 3 groups: admins, team representatives, and system features. Within the admins, they can create teams, users, cohorts, and factors. They can start simulations and progress the simulation. They can view the baseline results generated after starting a simulation, and also view team decisions and results as they are made. And they can create a postmortem report for the results of a cohort during or after the simulation ends. Team representatives can basically submit decisions for a team and also view past decisions and the results generated from those decisions. The system's job is to calculate the results based on the decisions. Some of the tools and technologies that we used were, again, Django, our web framework based on Python, a programming language. We used SQLite and PostgreSQL for our databases, Visual Studio Code for our code editor, Microsoft Azure for our deployment platform, and Discord for internal and client communication, as well as Gmail. Some of the useful Python packages that we used were Black and Flake8, which are code formatting and styling, used for code formatting and styling. Python.env, which loads environment variables from a .env file that can be used throughout the system. And OpenPyXL, which is used to read and write Excel files using Python. Some more about Django. Django is a modified model view controller framework. It uses a model which is heavily based on object relational models, ORM, to interface with the database. And you basically can model entities via classes, Python classes, and Django will natively handle the database creation and migration. With the templates, this is like the front end of Django. Django has a built-in template language where you can mix in Python and HTML, CSS, and JS, JavaScript. And it also accepts context from a controller. And the controller or view in Django is the middleman between models and templates, and it passes a context which contains information for the template to use. It also communicates with the model classes to read and write from and to the database. They're interconnected, as you can see from the image on the right.
Hi, this is Dave. I'm going to give a quick run through the Rogue Financial Simulator app. Let's start by logging in as an admin. All right, so upon login, the admin is taken to this list of cohorts, which are the sort of default value for grouping teams. Why don't we add a new cohort? All right, we've added our cohort. Now let's see about teams. All right, new cohort, no teams yet, so why don't we add a team? All right, we've successfully added a team, but there's nothing really to see yet. So why don't we log in as a team? Currently, a team doesn't have much interactivity. They can enter decisions and view results. There's no results to view yet, so these will be blank, but you can see they have the baseline decision values, but not the ability to enter anything yet, but we can change that. All right, once we hit start simulation, that unlocks the ability for the first team to enter decisions. So let's refresh over here. All right, now they can submit decisions. Well, that adds to the database and completes the calculations. Let's see what the admin will see based on that. All right, so now you can see that they have entered their decisions for year one. All right, so as of now, though, a team member can only see their year zero quantities. To release the results of those first year decisions, the admin clicks on the X. Now, yep, and the same flow continues forward. let's see about what other sort of views the admin can have. So we've gone over teams, the list of teams, but also from that page you can change the team's name if you like, or you can go to their team overview, which shows the same reports that they would see. Also, you can go to the analysis page, which shows a side-by-side summary. If there were more teams, this would be more columns extending out, one page for every year. And then this export feature exports a Excel spreadsheet of the results.
During development, we used two types of testing: functional testing, which was used primarily this second term, and that was manually ensuring that all parts of the program work together as expected to produce our desired results. The first term, we primarily focused on unit testing to verify the large number of calculations, and we did that via Python's unit test through Django's implementation. We faced a significant number of challenges during the first term. Primarily involved in designing the database. We initially designed it to be as normal as possible for flexibility, but it didn't work well with Django's approach to ORM, so we updated it to be more denormalized. Our second challenge was parsing the spreadsheet, which, as mentioned, contained a large number of data items and calculations. And finally, we encountered a lack of detail about the simulation details. Working with the client team, who were very helpful, but they were not the primary stakeholders for this project. There was a benefit to working with the dev team, and that was that they were very knowledgeable about the programming aspects, which helped us make a lot of progress. During spring term, we also encountered some challenges. We had to split the development of the app into the development and production versions. That was for deployment. Settings had to be split, but the real challenge came when running Django in debug mode the first time, when there was a lot of small problems that Django's debug mode masks. Our factors page contains a large list of editable values. Was taking a long time to load, and it was loading inconsistently on different machines. Finally, we encountered challenges with the exporting to PDFs. There was some serious formatting issues, which actually drove us to change into exporting into an Excel document. Finally, we'll talk about division of labor. Primarily, I handled the fundamental calculations, worked on authentication, report views, did most of the database design. I also sort of organized deployment, as well as a lot of other things, including adding and editing cohorts and teams via a custom interface. And I think I'll pass it now over to Mason.
All right, so I did mainly the cohort analysis, which is used to view the team's results side by side and compare. I also did the postmortem report, which is essentially the analysis, but it's exported. Used a package to export it to Excel instead of PDF, like Dave said, because there were a lot of formatting issues. It's ready to print after it exports. And then also I did the admin and team help messages inside the application. I organized a Discord notification bot so that we could get updates anytime anything happened on our GitHub repo. And I did the key data report and the unit testing.
So I worked on the decisions page, implementing submitting decisions via a form. The UI design, I created the initial wireframes and then designed the pages to be more user-friendly. And I worked on the cohort dashboard page for unlocking years. The admin can unlock years during the simulation. And the factors page for updating and saving factors. And the loan stats report and unit testing.
All right, and in conclusion, we'd like to state how our product improved the lives of the users And the primary improvement is that it reduces the amount of manual input from the administrator and gives team representatives direct access to the simulation rather than handing out paper to be filled out and entered. It gives the client a system that's easier to use and it's expandable for the future. So speaking of the future, there's a few things left as future issues, including modifying the calculations, ability to add factors and variables, some changes to the organization of the pages, more unit testing, further validating values, formatting the input fields on forms, and possibly reducing loading time on the factors page, among other improvements. Thank you, everybody. From Dave, Devin, and Mason.